Hello, everyone. I'm very excited to be here today to represent Cisco Cloud Networking team's product that provides us 360-degree visibility in a data center and cloud environment, Cisco Nexus Dashboard Insights. I'm Azim Suleiman, Director of Product Management. Joining with me today, Daniel Peta, Technical Marketing Engineer on our Cloud Networking team. He will be walking us through some compelling Nexus Dashboard Insight use cases, and we look forward to have an interactive network field day session together. One of the things that used to keep us up at late night is troubleshooting a data center or cloud networking problems. Typically involve multiple disparate teams, each having different view of the network, the user interface, and the application that we all support. Historically, it took probing the network manually with complex questions and the answers to derive from the custom scripting, the spreadsheet, and the CLI interfaces for troubleshooting and remediations. And with the scaling into the multi-cloud in modern data center fabrics, the size and the scope of deployments are growing into hundreds or even thousands of devices. This results in operational complexity, and the cost of managing these devices has exponentially grown as it takes longer to troubleshoot issues using multiple tools and the methodologies. These multiple tools result in disparate user interfaces that ultimately result in a long time for manual processing these data to troubleshoot and root cause them. It often requires time to hone into misbehaving devices and collect and analyze across multiple devices. This results in multiple large downtimes and becomes very expensive for the business. Traditional data center network management tools and approaches assume a velocity and volume of change that is well below what is enabled by the cloud and is unable to meet the demands of cloud native application and digital business requirements. Cisco Nexus Dashboard is designed to automate, monitor, and analyze your network infrastructure, innovative architecture approach implemented to provide full automation and visibility at scale. Cisco Nexus Dashboard Insights allows operator to consume the entire insights and assurance stack as one unified offering. It incorporates a set of advanced alerting, baselining, correlation, and forecasting algorithms to provide a deep understanding into the behavior of the network. It analyzes telemetry data streamed from multiple sources to provide perfect interception into hybrid cloud infrastructure. The Insight services uses analytics and deep visibility to pinpoint exactly why, where, and when an issue is originated. The open exchange of telemetry data with other tools such as AppDynamics extend the visibility beyond the network into application domain. Nexus Dashboard Insights simplifies operations from our customer with a modern stateless microservices architecture that can scale horizontally, leveraging an open source infrastructure as a code. Insight delivers dynamic correlation, impact analysis, proactive alerts, failure predictions, and remediating along with the operational data visualization. These capabilities help consolidate the number of operational tools needed and reduce application downtime, mean time to innocence, and mean time to resolution, and lower the operating cost. Let me give you a key architectural component overview regarding the Nexus Dashboard Insight. Collectors, Nexus Dashboard Insight incorporates a universal telemetry collector. These collectors support multiple input plugins for collecting software and hardware telemetry data streamed from networking infrastructure devices, such as routers, switches, firewalls, load balancers. Data Lake Insights pipeline support data encoded in JSON or GBP, which gets transformed and stored in a data lake for further processing. Telemetry data for legacy devices that doesn't support telemetry is retrieved using REST API or SSH and then put into the pipeline for transformation and correlation. Analytics engine. The analytics engine pipeline uses a serverless compute model. It handles the tasks such as data enrichment, anomaly detection, data aggregation, and resource scoring by splitting them into modular tasks with associated task specifications. These tasks are processed independently, and the results are saved in a distributed data lake. Insights proactively streams software and hardware telemetry from across the fabric. It uses AI ML technology to create a network-specific baseline for different key performance indicators or KPIs. These baselines are continuously updated to reflect dynamic network behavior. An anomaly alert is generated when the network state processes and crosses the threshold sets base over the baseline. These anomalies can further trigger user-specific actions and generate different types of notifications such as email or auto-remediation alerts. Now, commonly in network operations world, we see two types of changes. One is related to move, add, and change, and other is related to upgrade the software code or downgrade the code depending on the features and functionality that you require. To solve these problems, we have solved in two different fashions. Upgrade Assist gives a customer an option to upgrade different fabric with confidence. You will have a pre-check and the post-check upgrade and the drift between them, and it will give you the guidance with the recommendation. Detecting changes in configuration and orchestrated behavior before and after switch upgrade, controller upgrade, validated with 40 plus checks. Today, we are leveraging best-in-class AI/ML technologies to automate a number of different of these tasks. Those are done manually, CLI, or by custom script that customers generally use by Python, Perl, and other mechanics. This has to lead for powerful forecasting and anomaly detection use case to generate an alert-based analytics on the time series database, paving the path towards from proactive, predictive to prescriptive capabilities in the network operations. Insight has been built with the principle that is beyond identifying a problem in the network. There is a strong need to make the complex monitoring of IT operation simple. We embarked on an automation journey starting with taking additional steps to identify the impact caused by the issues and the resulting remediation steps. One of the key automation and visibility capability is the one-click remediations. Instead of giving you the huge data set, by applying correlation, ML techniques, and pinpoint anomalies which needs to be given attention, do you see anomaly in your network? Save the time for remediation by clicking one-click remediations and exactly giving the guidance, what are those next steps and how we will go and automate it. And when we do this learning, we can bring more and more goldens of these next steps for auto remediations and making it towards a vision of self-networking, auto-driven environment or autonomous networks. This ultimately reduces MTTR with one-click automated fixes that are commonly known behaviors. Let's start with the first layer of this architecture, layer cake. The bottom line is that everything that we do is all about the Nexus 9K, Nexus 3K, 5K, 7K, and brownfield install base. But our story starts with ASIC-based Nexus 9K capability product, which provides deep visibility. One of the top of the infrastructure is the native telemetry that we have open orchestration and automation with the policy that is used by the controller like APIC or DCNM. So we go up the layer cake, the Nexus Dashboard Insight with combined capability of Nexus Assurance Engine, all in a unified app. These applications really work like Apple and Android in the App Store. They run for both environments same way that customer doesn't need to learn independently. The cherry on the top of the cake is Cisco Nexus Dashboard provides a single agile automation to access data center network operational services and tools. Today, you can directly launch Nexus Dashboard Orchestrator or Nexus Dashboard Insight. It becomes even more collaborative focal point with the inclusion of operational critical third-party integrations such as ServiceNow and other applications. It can cross-launch for the controllers like Epic, Cloud Epic, and DCNM fabrics, which drives adoption of cloud-native application practices, leading to a faster path to ROI. With that, let me turn the floor to Daniel to show us some of these capabilities and real works. Daniel, over to you.
Once again, my name is Daniel Pita. I'm a technical marketing engineer for the Cisco Cloud Networking team. And I'm going to be covering Nexus Dashboard Insights 6.0. Quickly picking up one of the features we left off on the previous session was the OneView capability. This carries over into Nexus Dashboard Insights by showing us the multiple different site groups configured on my different Nexus Dashboard clusters. And even from Nexus Dashboard Insight, I can see all of these individual fabrics and site groups and view all of their information real time just by logging into one URL. Likewise, I can have a central dashboard here just like I did with the Nexus Dashboard visibility, and this gives me the information from the site group perspective that is inherent from the Nexus Dashboard Insights view. So here I have different site groups, TME Fabric. This is two different ACI sites, and once I click on the little tile, it automatically redirects me to a different cluster. But I'm still logged into the same URL, just API requests are being proxied and displayed on my current session. So I'll go back to my demo here for EFT Lab. And the first thing I'd like to point out with this new release of 6.0 that came out 2 days ago is the unification of long-standing product network assurance engine being incorporated or unified, merged, whichever word you decide to use, into Network Insights, which is itself a combination of Network Insights Resource and Network Insights Assurance or Advisor from a couple of years ago. So we might be familiar with some of the terminology from assurance engines such as Explore, such as Compliance. There's a Delta analysis that is probably very familiar to some of you. And change management has pre-change analysis as well. So the unification is really bundling these two products together, giving us the insights and anomaly correlation as well as the assurance that the network is behaving how we intended it to behave. And with that, I'm going to jump into the first demo, which is pre-change analysis. And this might have happened to some of you in the past, whereby you are trying to create a new construct inside your ACI fabric, and you just right-click and download the policy. And you didn't open it up in your text editor, do a find and replace, and just hit save and then post it back to the APIC. And sometimes it works, sometimes it doesn't. And the fact is that this happens a lot with operators just finding and replacing different attributes, such as just simply the name, since most of the other properties are going to be the same. And this could lead to potential outages during a maintenance window on Saturday at 2 a.m. So what change management and pre-change analysis is trying to help operators accomplish is really a successful change without any surprises at that 2 a.m. change window. So here I have a pre-change analysis called iSCSI bridge domain. And what I did as an operator was download an existing bridge domain, Control F, change the name vMotion to iSCSI, and then upload it to pre-change analysis with my change request ticket and the time when I would have that change request in the middle of the night. And what this tool did was take a snapshot of my network, hypothetically map those changes into that snapshot, and let me know what the result was. And I can do this at any time of day without actually impacting my network. So overall, this is the view that we can see. Quickly by these Venn diagram anomaly counts, I can see that before and after I had a total of 4 alerts, but I increased major alerts by 2. 1 warning came up, so for a total of 3 changes. Then scrolling down a bit, I can see it based off of different resource silo or categories. So bridge domain had 2 changes and subnets had 1 change. And finally, looking at it from the anomaly perspective, I'm going to change my view to only be the later snapshot. So this is showing me what I've introduced with this potential change window activity. So I have some forwarding policy alert that says overlapping subnets. Digging into these simply by double-clicking, I can see that the original bridge domain was vMotion, and it has this subnet 10.0.0.1.24, part of this VRF, part of this tenant. And it's telling me that these IPs are overlapping and will potentially experience intermittent or complete loss of connectivity. The reality is that what I did true was that find and replace for the name vMotion into iSCSI, and I forgot to change the subnet. Simple error, simple typo, but this tool caught it for me and prevented a little bit of troubleshooting, a little bit of a headache at that 2 a.m. change window from actually occurring. Likewise, we have the same anomaly from the perspective of the other bridge domain. So instead of subnet owner being a vMotion, it's now iSCSI, and it's letting me know that vMotion is the overlapping one. And finally, it's letting me know that even if this overlap was allowed by the network for some reason, the endpoint group will still not get deployed because the switch is going to come back to me and say, hey, that's an overlapping subnet. So I still can't deploy this endpoint group. I still can't deploy this VLAN. That being said, we can also look at compliance analysis. So if I did have some specific rules dictating what entities in my network can talk to what other entities, what VLANs, what ports or contracts they can use to talk to each other, I would have this compliance analysis letting me know that I might have violated one of my existing rules. This is very important for sort of HIPAA or PCI compliance, where I've established regulations that say what can talk to something or what cannot talk to. So instead of potentially introducing changes and failing on audit at a later point in time, the tool is showing me proactively that the change that I'm potentially introducing into the network is breaking my compliance requirements. And finally, we can even ask this hypothetical network change some questions via natural language query. And I have some of these pre-populated, but they are really autocomplete pretty much. So I'm looking at what bridge domains are associated with VRF, and then I'm going to pick my DP to VRF1, and it shows up right here. So based off of that model of the network and the hypothetical change that I've introduced, I can then see a list of pretty much answering the question that I've posed the tool with this natural language query. So what bridge domains are associated with this VRF, and it's showing me all of my bridge domains. I have a total of 9, including the one that I've potentially introduced to the network. If I did want to do a communication analysis and just, again, hypothetically, selecting the 2 that are overlapping, the tool is then going to tell me whether or not they can talk, and it looks like they can. It's a really simple communication pattern, so pretty much just what I put in, source being vMotion, destination iSCSI, and then it's going to tell me how do they talk. And it's pretty much showing me that they're talking source to destination in the same VRF, so no route leaking is going on, and what prefixes they're using. But hey, that looks a little strange. But nonetheless, the tool is letting me know that they can talk based off of a existing contract that's applied to the VRF level. But under forwarding, I'm going to have that same major anomaly or major warning showing me that these are overlapping subnets. So even if policy is in place to allow them to talk, based on traditional networking, they won't be able to, and the actual deployment won't actually happen. So it's a couple of different checks showing us what the network can do, and if I do fix this overlapping subnet, then they should be completely free of any anomalies, and I know for a fact that once I fix that subnet change, they will be able to talk and all will be well at the actual change window. And please let me know if you have any questions. I'm happy to take them. I'm going to move on to my next demo, which was one that Azim covered, which was a firmware update analysis. And I have these pre-staged. Obviously, network upgrades take quite a bit of time, so I had this staged a few days ago. But the initial process to get these up and running is selecting your target version for your controller and then for your switches, and then hitting the Run Pre-Analysis. I'm going to double-click on this since it's already been done, and we can see that it's broken up by 2 different actual checks, one for the controllers and one for the switches. And I can see my summary of nodes here, so 4 leaves, 3 apex, and 2 spines, going from version 5.1.4 to 5.2.2. So let's dig into the controllers first. We can see this overview, the nodes that I'm going to be upgrading, and their target version. And then the different tabs at the top are showing me the stages of my pre-update analysis. So the pre-update analysis has some built-in mechanisms to check, letting me know that my devices are active and healthy. I can go from my current version to my target version, no issues found with compatibility. Some specific checks for remotely for multi-tier capabilities. My route reflectors are configured correctly, and some other best practice checks such as NTP or SIMC compatibility. But there is one problem here under faults. It looks like I have 2 active critical configurations that I should remediate before upgrading. And then it tells me that I can go to this particular section in the APIC UI to then try to remediate those faults. Well, since this is a lab, I didn't really care, and I proceeded with the upgrade. So after the controllers go through their upgrade process and reboot and come back online, the post-update delta analysis.
Daniel, quick question if you have a second.
Absolutely.
Yeah, from that fault view, is there any contextual link out to a Cisco tech node or documentation explaining that note or what that fault is?
Well, this would be an operation you would handle on the individual controller. And the only note that we have in here is to go to system faults to find details on that fault.
So the workflow from here would then be to go up a dashboard or directly to that controller?
Go to the controller. Yep.
So you still have to leave this environment and go to the controller, log into that interface, and then go look stuff up.
That's correct. Yep. Either using your regular open a new tab and log in, or leveraging the SSO single sign-on functionality and just cross-launching.
So you can still launch. So you can still launch to get into that through this interface. Is what you're saying?
Absolutely, yes. If I minimize a few times, if I click on my site group,
So you guys just haven't done the part of linking and jumping directly to the controller and dropping to where the fault is yet.
That's right. That part has not been done yet.
Yeah, I'm assuming.
Yeah, we're working on more of those unified workflows and really showing the value of cross-launching and bringing up these individual faults. Yeah.
Okay, thank you.
Sure, absolutely. So under the post-update delta analysis, and I'm currently looking at the switches. And we can see here that it's showing me the same Venn diagrams from earlier, where I can see I've removed I removed a lot of faults. Actually, I had 64 earlier, and I'm down to 3. But I've introduced 2 major anomalies for a total of like 10 changes. And then we have a bunch of different categories showing health delta by resource, so whether or not what went up, what went down. And I can do this only via mismatching or not mismatching. My controllers are now on their final version. I can see the anomalies that were introduced. And moving on to the operational delta. From the APIC perspective, I can see that 3 events were introduced from this mismatch. And just scrolling down, you can see the different operational categories that we're collecting for the switches, and this will be more interesting when I go to the switches. So let's go ahead and click Done here. And under the switches, it's the same view, once again showing me the switches that I've upgraded in their starting version. And then under the pre-update analysis, there's individual checks being done here that are unique to the switches versus unique to the APIC. In this case, I have a fault for a spine redundancy check where in my lab, I'm only using a single upgrade group for all of my switches just for the sake of laziness, really. So they're all in the same maintenance group, so it's letting me know that there's going to be an outage. And if I want to avoid this outage, it's best to split my spines into different groups. But overall, I just went ahead with the upgrade. And it's showing me that pre-update, I have potentially affected endpoints, forecasted clear anomaly, and potentially affected release defects. So scrolling down, I can see potentially affected endpoints. I have about 21 endpoints that are going to be affected. These are single connected endpoints, and now obviously if my switches reboot, these endpoints are going to go unreachable. One of the cool parts is looking at the potential release defects, and this is all scraped from the release notes of my target version. And here we do have a little link to open up individual bugs straight from Cisco.com. So it's nice to be able to get this information about what potential bugs are available in the new version. So here's the link about the bug search. Yes?
Gotcha, Daniel. So in this workflow of doing the upgrade, is this augmenting or changing the workflow if I were doing this on the APIC directly, or is it just triggering the event on APIC? Because let's say I've got like 5 management groups or maintenance groups, right, for the spines and leaves, right? What's the workflow here on how that happens?
All right, so the workflow is typically creating the upgrade analysis on Nexus Insights and running the pre-update analysis. You're greeted with these results, and from here on, it's completely independent of the fabrics. To your point, if I did have multiple different fabrics or multiple upgrade groups, the workflow would either be to go to multi-site orchestrator and configure the upgrades for all my sites from one orchestrator, or log into my individual APICs and do the upgrades from there. And that's what I did in my case. It's just simply going to the standard admin firmware and doing the upgrade from there. Now the cool
Is
part
it pushing new maintenance group information, or is it just using what's already built there on the APIC?
is well, yeah, it's using what's already built. The tool isn't pushing the upgrade for you. It's just looking at your current configuration and letting you know that there might be a problem with it, with your current configuration.
Right, because I think, in some cases, right, each data center may have different tolerances and maintenance groups, right? So just trying to understand what's getting added or removed in that APIC policy.
Yeah, nothing is being changed from this operations tool. It's not pushing any changes.
Great, that's what I was looking for. Thank you.
Sure. Post-update delta then is looking at it from the switch perspective of what actually has gone up, gone down. The most important stuff that I wanted to mention here is the operational delta. So now we're showing me how many MAC addresses, IPv4, IPv6, host routes have changed from before the update to after the update. And this is incredibly valuable for operators to quickly see what has actually changed. All of my number of VRS, bridge domain, VLANs, these are all exactly the same, so it's not going to show them to me by default. Port usage is the same. Bandwidth is a little bit higher or lower in some places, which is kind of expected. VPCs, whether or not their admin state or upper state is up or down. So this is all great information to see, and we can see the different categories here: IGMP, Snoop, endpoints, hardware changes. Now, with that said, I'm going to jump over to one of our other use cases. This is a really short one, but I think it's pretty neat to show. I'm going to quickly search here for a description that contains BGP. Hopefully it's still within 2 hours, but this particular anomaly says that BGP peer session is in a closing state. Now, once I look at this fault, the feature here I'm showing is called a correlation. And the impact of this is that for this particular BGP fault, I'm showing that there's a parent anomaly that caused it. And essentially, this interface being down due to link failure caused this SVI interface on this leaf, which is being used to peer to this BGP neighbor, is the reason why the peer went down. So an external issue caused this interface to go down, and now it's being correlated to show that this BGP system went into a closing state. It's just a quick use case of some of the correlation that we're building into the tool bit by bit.
Daniel, is this from the maintenance event? Is that what we're connecting to here? We're saying this session went down because of the maintenance event?
No, good question. This is I moved on from the upgrade analysis into a new feature or use case here where we're just showing correlation.
This is only within that single cluster, right? You're not seeing the event correlation across. So if the interface is actually, happening for a WAN-based port or across to another cluster of any type, you're not going to get correlation between the two endpoint interfaces going down across the link. It'll only be within the cluster itself, right?
That's right. For today, it's just what this single cluster is connected to. Now, that being said, if I had multiple fabrics on this cluster, there would be some manner of correlation showing them all in the same UI, but not correlating one interface on one end to the other interface.
Right. If it's within the cluster, you're going to get all the correlation because of the fact that it's within that cluster set, and the events are going to be correlated then, right?
Yes, sir.
Yeah.
That's correct. And if you see the reason to build this in a modular way is once I've done the correlation within the one fabric or within one Nexus dashboard cluster, and I already have a global aggregated view, which is the Nexus dashboard one view, I can easily do correlation across multiple ND clusters and then can show you in the same global view. So that's how we want to go in modular way.
So I'm going to try to find one more workflow here, and I'm not sure I'm going to be able to, but the idea was that users in this ordering endpoint group are complaining that they cannot complete their transactions with their online ordering tool. So simply by putting in the EPG called ordering web, there should have been an anomaly showing a bunch of packet drops. I'm going to change my time frame here. Maybe it'll show up. Last 2 hours, maybe? Here we go, packet drops. Well, by looking at this particular flow, I can see that I've had 384,000 packet drops, and we can see here that they are policy drops. So simply by looking at this, I can see that there's a problem with my contract, but I'm not sure how or when that happened. So leveraging the unified tools that Assurance is bringing in, I can quickly do a delta analysis, and I know that when I came into work this morning at 8 a.m., this was working just fine. So I create this delta analysis, selecting an earlier snapshot, 8 in the morning when I came in, to a later snapshot to when this issue was originally detected. And the simple Venn diagrams once again appear, showing me that I have one new critical anomaly, and that's pretty much it, one total event. So looking at it down below, once again, I can select the later snapshot only. I quickly see that my compliance for SLA is being violated. And double clicking on this will show me that I have an existing rule that says ordering app web, talk to app on port 443, or my source EPG is ordering web, destination EPG is app, and they're only supposed to talk on port 443. And since this is being violated, that lets me know that there's a problem and my contract is broken for some reason. So why did this break? And I can quickly take a look at the policy delta to then see, be quickly dropped into what is an audit log showing me that this subject was deleted with a filter of 443 from the contract, thus breaking communication to the between the app and web tiers. And the nice part is that I can go to Explore and also like check my DVR essentially and select the snapshot where that happened. I believe this was introduced around here. I can quickly ask, can PG have ordering web talk to endpoint group ordering app tier? So they cannot talk. So it is really clear that these endpoint groups cannot talk, at least based on this timestamp.